Hey friends, you should be able to hear me. This is my first time trying this, so I'll do the best I can. And as I get better at it, hopefully this will get better too. So what my goal is here is to hopefully every day I'll have it so that I can post a lesson for you and you can follow along and ask me questions as I go. Right now, the first lesson that I'm going to go through is solving exponential equations. And when we're talking about when bases are the same, right here, when bases are the same. So really an exponential equation is an equation where we've got a variable in the exponent. So something like this, simply 2 to the power x. That makes it an exponential equation. Remember before the break, we tried to graph these things and play around with them, okay? Our goal is we want to solve for that exponent, right? Because the unknown's that exponent. So we're going to have two ways to do this, right? Remember what I've said a million times? If you're not cheating, you're not trying hard enough. First thing you should always do is try to solve it graphically, okay? More importantly, though, is what do we do when we're asked to solve it algebraically? And how we're going to do that, my friends, is we're going to make the bases the same, okay? What you're going to see is actually this isn't too complicated. You're going to like this more than rational equation solving, but you want your calculator with you. Okay. So question number 1 here says, ooh, I don't like that. Move. Okay, it says right here, write 9 to the exponent 2x with a base of 3. So what I'm going to do is I'm going to change how this looks, not what it's equal to. Well, I know that 9 is really 3 squared. So I haven't changed the value of it. 3 squared is 9. Now I can use my power laws way back from grade 9, but what I'm going to do is I'm going to combine these two together. I'm going to simplify it, right? And to simplify it, an exponent to an exponent, I multiply. Boom. So 3 to the exponent 4x. What this tells us is that is the same as this. Those are the two things, same things. They look different, but they're the same. Okay, next one says change that to a base of 5. So again, I'm not changing the value of it. I'm changing how it's looking. 125 is 5 cubed. Now I know that because I've been doing this a long time. If you didn't know that, you're going to pick up your calculator and you're going to go 5 to the power of 1, 5 to the power of 2, 5 to the power of 3. You're going to try that until you get 125. And now again, using my exponent laws, I'm going to multiply that to both terms in the exponent, and there it is. Okay, the last one here, number 3, is the trickiest one. Okay, all of a sudden our 512 is in the denominator. Don't worry about that for a second. Okay, so again, I'm changing the 512 to be a base 2. So I pick up my calculator and I go 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7 gives me 512. Now, what that is then is 1 over 2 to the 21x, but I don't have a base of 2. My 2 is in the denominator. So remember way back to grade 10, to bring that to the numerator, I make the sign on my exponent negative. Just like that. Okay, now this isn't us solving here. This is us moving or changing how this looks. Okay, now here we go. Now what we're going to do is we're going to solve. Now again, keep in mind, I could solve all these by graphing and cheating, but I need you practicing doing this algebraically. Okay, question 1. It says 5 to the 2x plus 3 is equal to 5 to the 7. Well, notice the bases are already the same. So if the left-hand side is equal to the right-hand side, and the bases are the same already, well, what that tells us, if this is an equation, they're equal, well, therefore, the exponents then are equal. So I don't need the bases. It's not like I canceled them or I divided them out. If the bases are the same, then the exponents are equal. I simply don't need the bases anymore. Okay, that was an easy one. Too easy for us in grade 12. Number 2. Okay, my hint here is that I'm going to make the 343 into base 7. So I go and I figure out that 7 cubed is 343. Each base is the same, so now I make the exponents equal and solve. Boom. Just like that. Okay, next one. You know, again, as soon as I start seeing fractions like this, what I'm going to do is I'm going to think I'm probably going to have to get whatever is in the denominator into the numerator. Well, 16 is 1 over 4 squared. So to get that into the numerator, I change the sign on my exponent to be a negative, right? And now again, since my bases are the same, therefore my exponents are equal, and I can solve. Now, that wasn't too bad, I hope is what you're thinking. How do I check my work? Well, I just take my 3 answers, or any of my answers, I guess, and I sub them back into the original equation. If the left-hand side equals the right-hand side, guess what? You did it correctly. Now, what it says underneath is the next question is going to say, solve graphically. Well, graphically is actually, again, if I'm thinking of what I say in class all the time, I'm thinking of, hey, if I'm not cheating, I'm not trying hard enough, and my parents bought me this lovely graphing calculator, I'm going to graph, right? Okay. Now, I'm just freehanding this thing, but generally what I'm going to do is I'm going to say y1 is the first guy, y2 is the second guy, and as I graph these things, there's y1, here's y2, and again, I'm just kind of freehanding this, so your graph that you're going to see isn't going to be the same as mine, because I'm just making it up. Our solution is where these two graphs intersect, right there. So guess what? Your point of intersection is going to be the same as the answer that you had above. Okay, well, that's going to be at 2. Okay, now, well, when x is 2, it's going to be 2 comma, it's going to be a really big number, actually, guys. It's going to be whatever the heck 5 to the power 7 is. It's going to be a massive, massive number. Okay, remember, I don't actually have to see that point of intersection. Okay, if I don't see it, no big deal. Just try to find it using your calculator. Try finding even if you don't see it. And we've been practicing that all year long. Okay, but for what it's worth, it's probably just easier to do these questions algebraically. I want you thinking that, and thinking that I can pick up my calculator and check all these things graphically when I'm done the question. Okay, let's try a couple more. Okay, there's not much more to it. There's only a couple of small tricks here, and I don't know if I want to call them tricks. There's only a couple of small things that pop up as we're doing these things. Okay, and I'll cover basically in the next 3 questions every sort of quote unquote trick that I could possibly see. Okay, so here I see my 2 bases. One's a base of 9, one's a base of 3. So I'm going to make them both base 3. How I'm going to do that again, I'm going to change how it looks, not what it's equal to. So 9 is really 3 squared. I'm going to simplify my exponent by multiplying everything by 2. Once my bases are the same, therefore my exponents are equal. And again, from here, now you're just solving a nice little grade 9 linear equation, right? On the next one, all of a sudden there's this coefficient of 2 flying out. Okay, the wrong thing to do. This is wrong. Don't do this. Students will sometimes multiply those 2 things together. You can't do that, right? One's a coefficient, one's a base. We can't do that. No bueno. Don't do that. Okay, here's the right way to do it. I'm going to divide both sides by 2 first. Now, what I'm going to say to myself is, can I make the bases the same? Answer, yep. Okay, bases are the same, therefore exponents are equal, and L solvable. Okay, so the key thing that I want you to take away from that is if there's a coefficient, you can't multiply coefficients and bases together. And again, that wouldn't be a bad time to go and graph that thing and to check my work. Okay, next one. I need you to remember something way back when something is written as a square root, that's the same as me saying it's an exponent of 1/2. Okay, so the first thing I'm going to do is when something's ugly, I'm going to put some makeup on it. I'm going to change how it looks. Boom. Now that I've gotten rid of that radical, I'm going to say to myself, let's turn 125 into a base 5. Now again, if you don't know what that is, 5 to the power of what? You pick up your calculator and you try it until you get there. I know it's 5 cubed because I've been doing this forever, right? Now all I'm going to do, simplify the right-hand side. So 3 times 1/2 is 3/2. Bases are the same, therefore the exponents are equal. Now, a lot of us don't like working with fractions. I'm just going to turn that into 1.5. Okay, it might make your life a little easier. I'd prefer if you worked with fractions, right? You guys know that. You know my love affair with fractions. Okay, but if you don't like them, whatever, turn it into a decimal, right? As long as that thing, you're not truncating or terminating the decimal. Okay, there it is. So again, watching out for right here, if I got a coefficient, I'm dividing it, right? I'm getting rid of it by dividing. If I see a radical flying around, I'm going to turn it into a rational exponent. Bueno? Now, almost done already, guys. Look at this. You're rocking. We got this. Okay. Now the next one I say, look at this. It says solve graphically, but you know what? Let's try and do this thing algebraically first. Okay. Algebraically, I'm going to try and make the bases the same. So we're sitting in class together. I say, okay, friends, make the bases the same. And you all sit there for a few seconds, and then finally someone shouts out, you can't. And I say, yeah, kinda, you can, but it's certainly not easy, is it, right? I don't really know 2 to the exponent of what, some number, I don't know, is going to be 7. I have no idea what it is. I know it's going to be a little bit smaller than 3, right? Because 2 cubed is 8, but I don't know for sure. So guess what? When we can't make the bases the same, I can't solve this thing algebraically yet. No algebra yet. No can do yet. Okay, guess what? That's why we have those things called logarithms we looked at, but we'll save that for another day. So the only way I expect you to solve 7, 8, and 9, if I can't make the bases the same, guess what? Easiest thing in the world. Graph it, baby. Okay? Your other hint, if you see a question that says round your answer to the nearest 100th, guess what? That's a clue. Graph it. Okay? If I don't tell you in the question, solve algebraically, if I say just solve, I'm not telling you what to do. I'm saying solve. I'm okay with you graphing it. Okay, I want you to keep that in mind. Okay, so we'll worry about how to solve things when we can't make the bases the same using logarithms, which is sometimes not that bad. Okay, but we'll worry about that another day. Okay, last question, my friends. So the real reason why, again, we study these exponentials right here, exactly, unfortunately, what's going on in the world today. This is a question about bacteria. Well, we could easily change this to say, this is a virus, okay? Exponential equations model a lot of stuff in nature. Remember, we talked about that on the first day. So when I get these things, remember, I'm always trying to figure out first off, what the heck are these crazy variables he's throwing at me? What's T? T is time and days. Boom, got it. What's P? P is the number of bacteria. Got it. Okay. A, determine how many bacteria there'll be in 25 days. Okay, so I say to myself, that's T. Okay? So I'm saying, let T equal 25. Okay. So no real algebra here that I need to see. I'd really like you to show me your substitution. Now, the only thing that goes wrong here, some of you with TI-83s or the white Casios, is you need to put that exponent in brackets like that, right? I should have said parentheses there. We're in Canada. And now you just got to slam that thing in your calculator. Okay, you're going to get a big number. Now, you're going to round that. I can't have part of a bacteria, right, friends? I can't have a part of a bacteria, so I'm going to round that to the nearest whole number, whatever that happens to be. Now, B, how many days until, that's time. That means P is 12,500. So I'm going to graph this thing. I'm going to sub in that value, I should say, first. I could graph it right there, but the first thing I'm actually going to do is I'm going to divide both sides by 2,000. Okay, dividing both sides by 2,000 makes my numbers a lot smaller. Okay, divide both sides by 2,000. I get 6.25. Now, sorry, I didn't leave you much room to write here, hey? I'll fix that for next year. Okay, now, I can't make those bases the same. So what I'm going to do right there is I'm going to graph that. So I'm going to my calculator. Y1, 6.25. Y2, 2 to the exponent t over 6. I hit graph. Again, I don't really care. Like, I'm just, as my window settings pop up here, I'm looking at it. I don't even really see the point of intersection. I'm not too concerned. I'm just going to try and go second calc intersect, or Casio shift G solve intersect. And guess what? I get 15.86. Now, there's no rounding instructions. Well, I'm going to round that up to 16 days, because if I rounded it down to 15 days, I wouldn't have the required population of 12,500. So I'm not using the rules of rounding per se. I'm using the idea that I need to make sure that I've got enough of a population to cover what the question asked for. Okay, so here we go. We're almost done. Summary. You've got two ways to solve an exponential equation. I can graph that baby, or I can make bases the same, or algebraically, right? Use some algebra. Okay. To solve an equation graphically, we determine the x coordinate of the point of intersection. Right? You've been doing that for a long, long time. To solve an equation algebraically, we must make the bases the same. Then we know that the exponents are equal. Okay, we should always check our answers by subbing whatever our answer is back into the original equation, or I've got this lovely blue box here, I have no idea why, or by graphing it. Okay, my friends, that is my first attempt at a lesson online. I hope you liked it. I want you to let me know if it worked, if it didn't work. Hey, there's my ugly mug. We'll see what you think of this. This is what I'm going to try for the rest of the course. Okay, so email me back. Maybe let me know how you're doing, and hopefully I'll chat with you soon. See you soon, friends. Bye-bye.